So I will post both of them one by one, part one, part two kind of thing. Okay, all right. So I'm sharing my screen again. So I'm recording again, right? So if it is a cloud recording, I don't really need to worry about it. But this is not cloud recording. So I'm just going to the PowerPoint slide again, the same PowerPoint slide. Okay. So we were somewhere around here, right? This we completed already, right? And we came here. So this is what we were trying to do here, right? So 10% MAR is minimum acceptable rate of return. Take this like an interest rate. Take this like interest rate. So the present benefit is is positive. Okay, the effective present worth is positive. The overall, right? Taking into consideration this is a benefit. Your cost is minus 100,000. So overall, this is positive, then invest. Otherwise, don't. So are you getting 10%? No. If it is negative, you're not getting it. If it is positive, you're getting more than 10%. Did you understand me? Hello? So the current cost is 100,000. So the benefit annual is 9,000. Do you agree with me? And you want to find out the P given a 10% interest rate and 15 years. Okay, he gave you all the numbers there. And then find out this is the benefit, the present worth of the benefit, the present worth of the cost. The difference between this is net present value. It's called NPV. You understand me, right? So NPV, all right? So if this is positive, then your I, your I, right? This is minimum acceptable rate of return. Acceptable rate of return, MAR. So what is the MAR that makes this value to zero? Okay, you can compute IRR if you wish to. And that percentage is bigger than 10%, then you accept it, which means that so unless you have a higher value, this number won't be higher. So unless this is higher, this won't become zero. You understand me? So that means what is the interest rate that makes it zero? So that is the rate you're getting it. Okay, but you need only 10%. So that means more than 10% is good, less than 10% is bad. You understand me? So right now, this is minus negative value. You understand me? Which means that 10% is no good for you. The 10% you are not getting 10%. Okay? On your investment, okay? You are not getting 10%. You invested this money, right? Isn't it? So that means at least you get that money or more. More than that, obviously, right? Isn't it? But you're getting 9,000 for 15 years. The total benefit is only 68,455 today dollars. So overall is negative, is bad. Okay? Don't invest. So if the terminal value, solvable value is zero, okay? That's what we assumed anyway. So 15 value, so minus 1,000, 100,000 minus 100,000. Okay, minimum acceptable terminal value is zero. Terminal value is zero anyway, right? We didn't do anything. Don't invest. Annual benefit is not enough. Okay. What's the difference between these two numbers, the two PowerPoint slides? It's the same, right? Isn't it? Because you assumed anyway the value of the investment is zero anyway, isn't it? I think I think I was saying that, okay. I was saying that I should write a question like that to be very clear. All right. If the terminal value is 50,000, okay, I was changing the question to add some 50,000. That means, at the end of the future dollars is 50,000, okay, and convert that also 50 to present value, okay. So this is annualized benefit, already annualized, okay. You can also do annualize if you wish to, but I'm converting to present value and converting to the present value, the future dollar to present value, and the overall present value is 80,000. Still not good. Even the terminal value is there is not good. Okay. So the terminal value, so what should be the terminal value so that it is going to be good? So S is not known to you. So what is find out the S. So if you put your terminal value is 131,772. So okay. So your benefit is going to be exactly same as 100,000. So that means net present value of that investment is going to be zero, right? Isn't it? Net present value is going to be zero. So you are getting the 10% for sure. Okay. If it is more than positive, then you're getting more than 10%. You want at least minimum 10%. So payback period means it doesn't count the time value of money. Payback period. For example, I invested 100,000 today. Okay. And I'm getting, 10,000, 10,000, 10,000 for 10 years. I got all that money back. Okay. That is called how much time do you require? That is payback period. Payback period, you want to minimize the payback period because you want to get that money quickly as possible. You want to minimize payback period. But the problem with this is the payback period doesn't account for the time value of money. What is it actually? It doesn't account for time value of money. What is the meaning of time value of money? The interest. Interest is the time value of money. So that means you are not accounting the interest here. Payback period, break-even analysis, they don't include the interest. But you want the interest also to come back to you. All the analysis you did so far, you are including the interest rate, not excluding the interest rate. Payback period is not a good analysis, to be honest with you. Why would you require payback period? Because when you are paying interest to the bank. So there is an investment of $1,000. Okay. So that means, you have a payback, two alternatives you have. So another alternative is 2,727 $2,783 investment. The benefit also is like first 2 years is $200, next 3 years is $1,200. So all $1,200 a year throughout the period, right? Isn't it? So which alternative should you select? All right. So here, right? Are you getting all of that money back? So are you getting all of that money back? Okay. $100, $100, and $1,200, right? Isn't it? So that means you invested here, right? You invested here. Oh, sorry for that. Okay, let me just go back again to the. First of all, let me see if I am okay. Discard. I've opened this again. I don't know how I won't have the other one like. Okay, other analysis techniques here. Okay. Payback period right here. Look at it. So your money you get here, right? So you got, okay, first 2 year you got $400, right? Isn't it? And this one you're getting it in third year, you get, you need to get $600 more. So you got 2 years here. Come on. You got the 2 years here. 400, 400 is, 200, 200 is, this one. Look at it. 200, 200 is, I want to write it with my pencil actually. Escape. I don't want to keep that. Discard. Okay. Okay. All right. Let's look at it again. The first 2 years, right? You got $400. So you still need to get $600. That's what you need to get. But the third year is getting you $1,200. That means half a year you get $600. So your payback period is 2.5 years. Then later on, whatever is happening, you don't care that. It is the more money you are getting afterwards. You understand me? Hello? So the payback period for the first alternative is 2.5 years. Whereas the second alternative, so this one is 2,400. The remaining money is 383, which is like one third of this money. 383 is like close to the 400. So which is like, so 2.3 years that you require. So which one is less time here? So 2.3 is less than 2.5. 2.5 means 2.5. So that means you need to choose alternative B because you want to get your money back as quickly as you can. But you may say, sir, you know, these are not really realistic examples. You know, why the second investment is getting 1200, 1200, 1200, whereas the first investment is getting you 200, 200, and then 1200. Whatever is numbers are given to you, you start from the beginning, try to get that 1000 back to you. That is the time that the break-even analysis. Do you understand me? Hello? Anyone, Arash? Are you there?
Yes, sir, all good.
Yeah, everything good. Okay. So now let's look at another example here, payback period also. Two weighing scales. It should install, okay, package filling operation for 6 years lifetime. Okay, Atlas scale and the Tom thumb scale. There are two scales here. The car $2,000 and $3,000. The uniform benefit, like every year benefit is 450. And the salvage value is there, but salvage value is end of period. Don't care. Break-even analysis. So you have, unless you go to that place. So $600 uniform series for 6 years, right? Isn't it? So take this, 2000, divide by 450. And how many years? 4.4 years. So the terminal value is, the salvage value is coming in 6 years. So don't even worry about that. So the second one is 5 years. Okay. So $3,000 is the cost, and that divide by $600 uniform series. So that means 5 years. So the first one is better than the second one. Atlas is better. Is it clear? Straightforward question. So, like payback period is the time at which you get the initial investment back to you. Okay. How many years do you require so that you get your initial investment back to you? The first one is 4.4. The second one is 5 years. So obviously 4.4 is better than 5 years. You get the money back quickly. All right, sensitivity analysis. There's another analysis called sensitivity. I think I probably add a little bit more examples here. Okay. So I got few more examples. I may add it later. So since economic problem solving is often the future consequences, which is uncertainty regarding the accuracy. So small variations in the A state would change the alternative selected, obviously, right? They're data dependent. So sensitivity is usually, uh, you know, um, what if analysis. What if I do this? What if I do that kind of thing is sensitivity analysis. Okay. Usually a marginal increase in, in the resources may have a profound increase in the result. So you would like to do that increase. For example, when I'm cooking, cookies, for example, or, at the end, you may run out of sugar or something. So as a result, you are wasting other ingredients. So if you have 5 grams of sugar, you would have made one cookie. The cookie will be $1. Will profit maybe $1 on the cookie, whereas the cost of this pinch of sugar is like maybe 5 cents. So which means that 5 cents is making you $1. So that means your solution is sensitive to that resource. Whichever resource is shortage that you want to really see the effect of that, is it really going to increase your profit or not? Tim Hortons, the demand for the donuts is 400 and 600, right? Donuts and cookies. Okay, 400 and 600. So the profit for each of them is, so the cookies is 0.25 and no, donuts is 0.25 and cookies is 1.1. Okay. So the Tim wants to choose between cookies and donuts. So what should he make, right? Make cookies or donuts, or what should you do? Okay. What should be the demand for the cookies? Unable to create temporary holder. Okay. Hello, do you hear me? Hello,
Yeah.
hello. So the demand is $400, 400 for the donuts, and you're making 0.25. Multiply that. Multiply this is two. That's the total amount of profit that you're making on the donuts. You understand me? Hello. And the profit you're making on the cookies is $70 because 700 multiplied by 0.1 is $70. Do you agree with me? If you make one more cookie, okay, for example, all right. So what should be the demand for the to induce Tim to make one more cookie? All right. What should be the demand to make one more cookie? That means both should be equal, right? What do you mean equal, sir? So that means no. So if it is 1,000, it will be like Tim should make donuts because you're making more profit on the donuts, right? Isn't it? Oh yeah. Okay. All right. So can anyone tell me how I got this? 1001. Hello. Okay. So the cookies, right? How much money are you making? 1,000. Donut. No, not the cookies are donuts. Donuts. Sorry. Donuts is making $100. Cookies, how much money is making? $70, right? Isn't it? Hello? The demand right now for the cookies is how much? Is 700, right? Isn't it? Hello? If you increase the demand to 1,000, how much profit will you make at cookies? Hello? It will be 100, right? Isn't it? So that means if your demand for cookies is 1,000, you don't know whether to make cookies or donuts. Both will get the same $100. Do you agree? But the demand for cookies is 1,001, then you will make cookies rather than donuts, right? Isn't it? Do you agree with me? Hello, do you understand me?
Yes, because we're gonna pass 100 then.
Yeah, exactly. Excellent. Thank you. So because right now the demand for the cookies is not enough to decide upon to make the cookies because you are not making $100. The donuts is making $100 for the same resources, whereas the cookies is only get you $70 for the same resources. Okay? But now your demand is increasing to 100, for example, 1,000. Then you make $100. At that point of time, you probably don't know whether to make cookies or donuts, but you demand is 1001, you certainly, so demand is sensitive to the changes to the decision is sensitive to the changes in the demand, right? That's called sensitivity analysis. And in fact, I was telling you earlier, right? What if analysis is sensitivity analysis? What if I have some more resource, then I will make one more cookie or one more donut. So that I'll be willing to pay up to the profit that I make for that resource, even though it's not really costing you that much. For example, I ran out of sugar, okay? And a pinch of sugar will get me a cookie or donut. Donut will cost you, for example, you said 25 cents, but okay, 25 cents. Okay? But the pinch of sugar is only costing you 5 cents, or even less than that. So for the pinch of sugar, that is, so you will be, even if you pay 5 cents or 10 cents or 20 cents, you still make money. 25 cents, of course, you are not making money because the profit that you make is only 25 cents. Why would you pay 25 cents to get one pinch of sugar? So you will be willing to pay up to, but not that, okay? Still make profit. That's sensitivity analysis. Break-even analysis, okay, is a kind of sensitivity analysis because you want to break even and then go move forward in the forward direction. There is a place where your demand is exactly the break-even point, okay? That means you are not really going to invest. Your demand is more than your break-even point, you would like to invest, okay? It's exactly the break-even point you don't want to invest. A break-even point is the number of items that you make. You understand? Break-even quantity. Break-even quantity. Okay? Break-even quantity. Q, it's also called break-even point. Break-even point is basically break-even quantity. It is the number of items that you produce so that you get the fixed investment back to you. So for any investment, there is a fixed interest, fixed cost. Okay, you understand me? Fixed cost? The machine cost or some cost. So for any item that you're producing is a variable cost. Variable cost is direct labor, direct material. Direct materials cost plus direct labor cost plus overhead cost. Suppose you're making cookies. So what are the direct material that you need? Hello? What are the direct material that you require? Just think and just tell me, you all know it. Some flour, flour, and you need some oil or, some,
Baking soda.
yeah, baking soda, and you need sugar for sure. So you need some oil, I think. You need some oil. So you need, some butter. So that kind of thing. Maybe eggs you require. And direct labor, the people who are making them, right? Are direct labor. Who people who are the chef who is making that is the labor. Overhead. What is overhead? That is operating costs also. Not fixed investment, but operating costs only. The energy cost, There is a sweeper sweeping, right? Your floor, somebody is cleaning, sweeping, and your manager is also working with you, but he is not is not directly working on the material, but he's supervising you. He's the overhead. Energy is the overhead. Cleaning the floor is the overhead. So all that can be assigned cost. Assigned, you will not be, the supervisor is not working only this work, but his paycheck will come from every material, everything he's doing. So that's a variable cost. Okay? And each cookie you're selling, there is a revenue for it. So fixed cost equal to, okay? So variable cost per item multiplied by the number of items. Okay? So this much of money is the total cost, isn't it? So add this one to the fixed cost plus the variable cost is the total cost is equal to price of an item multiplied by Q, which is the total revenue that you're getting. So which means that you take this variable cost and the Q to other side. So fixed cost equals to RQ. R is the price of an item. Okay. Q is the number of items minus VC multiplied by Q. So which is nothing but Q multiplied by R minus VC. So the price of an item minus cost of an item basically is the profit per item. So that means the Q equal to fixed cost divided by R minus VC. So what is this Q? That is the break-even point. Q break-even point. You understand me? So these are the number of items you need to produce so that you get your money back. What is your money investment? Fixed cost is your investment. You invested that money and you're getting that back in terms of profit. So how many items should you produce and make profit so that you get the fixed cost back? That is the break-even point. So let's give an example. Two-stage construction project. First stage is now 100,000 and the second stage is 120,000. N years from now, right? Isn't it? All right. The full capacity project is 140,000. So 40 years regardless of whether it's all. The annual cost of operation maintenance are the same for both of the construction. 8% interest rate. Which one should you choose? So which one is giving you back less amount of, less payback period or less break-even point? Okay, that's what the solution is, right? Isn't it? So you can plot both of them and you see the first option is, second option is 140,000. Okay, full capacity project. Two-stage project has to be two-stage project. Okay, two-stage project is, okay, 100,000 now and n years later. So what is that n that makes both of them are the same? Okay. So for example, the first one is this one and the second one, the present worth of both of them. So today 100,000 is today 100,000. Doesn't really change. The future 100 to 120,000 future value, I want to convert to present value. N I don't know. So, all right. N I don't know. I can put N equal to 5, 10, 20 and 30 and try to find out different values and try to see where is it crossing that 140,000 between which numbers. You understand me? Hello? So now let's look at here. In 5 years, if I put 5, this factor of the first project, two-stage project, is going to be 181,000. Okay? If you put 10 years, for example, this number went down. So 20 years, the number went down to 125. You can stop there. You don't need to go any further. Don't even compute this one. Okay, you waste of your time. In fact, you computed means you didn't know. You already got that 140 is between 10 years and 20 years. You understand? Okay. You can even plot that into the chart here and try to see. The full capacity project is 140K. That doesn't change. Okay. So the second one is actually going down, down, down as you're increasing the period, and then break-even point is 15 years. That means both are exactly the same investments. So at the beginning, okay, is it a cost, right? The cost. So this is better at the beginning because it's a cost. Okay, 140,000 cost is better than this higher cost here. Look at it, higher cost. So the first one, if you say, okay, if you put zero there, for example, n equal to zero, you put here, right? So what happens is $220,000. Do you agree with me? Hello? This one is 220 if n equal to zero. Hello? So which means 220 is here. So at the beginning, right, this two stage is better. So after 15 years, so two stage is not better anymore. The full scale is better. So the time of operation here is 30 years, then you would like to have full scale, not two stage. Do you agree with me? Hello? Your time of operation is less than 15 years, then don't put that into it. Go to the full scale. Okay? So what is that n you want to find out, which both are exactly equal, for example. So equal to 140. So take this one. I can use my formula. This is the given future value. This is the present. You know the formula, right? P equals to F divided by 1 plus I to the power n. So, okay. So that's what the formula is. All right. Okay. So this formula here, look at the formula, is basically finding out the present value given the future. Oh, given the future, yeah. The future is given, finding out the present. This is the formula. Okay. So so that means future multiplied by the factor is 1 by 1 plus I to the power of n. This is the factor. So which is 1.1 divided by 1.08 to the power of n, and you don't know the n. Okay. To the power of n. All right. That is basically, so 1 by 3. You know how I got the 1 by 3? Take this one to the other side. So the difference is 40,000. So 40,000 divided by 120,000 equal to 1 by 3. And then n is 14.275. So real break-even point here is 14.275. Exactly. Okay. You said 15, but it's not really 15 exactly. It is in between. We said approximately 15, but it's not really 15. Okay. We see the present worth of the two-stage construction decreases and the second stage is deferred, right? And then where both are them exactly the same, right? It's called break-even point, and that is okay. So 14.275 the break-even point. All right. You can do future worth analysis, you can do cost benefit analysis, you can do sensitivity analysis, you can do payback period analysis. These examples, first time this lecture notes is not that great lecture notes, to be honest with you, because I did teach break-even analysis at length, much more than what I'm teaching you here. And the sensitivity analysis also I taught much more than this. But there are other courses that cover this. All this is only introductory economics. All right. Anybody has any question? I completed what I wanted to teach you, but let me show you. I have another lecture notes here. Payback period, net present value analysis, IRR. In the last lecture class, I already covered the IRR. Payback period is break-even point. Discounted cash flow, that's net present value analysis, is called discounted cash flow analysis. IRR, internal rate of return. Profitability index. Okay. All right. And net present value with uncertainty. There are several things I was teaching. How many slides I have? I have around 8 slides. Not bad. Because the lecture I was teaching here, another lecture notes is uncertainty analysis. Project cost is $100,000. Annual cash flow is, okay, cash flow means cash in minus cash out. And net is 25,000. So it takes 4 years for me to get that 100,000 back. That is the payback period. Present worth equals to future divided by 1 plus r to the power of n, r and 1 plus I to the power of n. So that is converting the future dollar to present. This is factor. So it is nothing but f multiplied by 1 plus I to the power of n. This is the factor. This factor is basically, okay, finding out the p given f and I and n. This is the factor. And that is the formula. So if you invested $10,000, right, today, and your revenues is $5,000, $4,000, and $3,000, you convert this to today dollar using this formula. Okay, that is 4,630. This is 3,429. So add them together, including this. Whenever you put a bracket here, parenthesis, right? Can you tell me what the number is? It's a negative number, right? Didn't I give you in the exam? Hello? You see, if I put any number in the parenthesis, what does that mean? Hello?
Negative.
Yeah, it's a negative number. So that means minus 10,000 and add all this together. All of them, add them together is a positive number 440, which is you are making more than 8% because the discount rate is 8%. So this number here, 5,000 divided by 1.08, 1 plus R is 1.08 to the power of 1. So this one is 4,000 divided by 1.08 to the power of 2. So this one is 3,000 divided by 1.08 to the power of 3. So you got this. This one is exactly 2,381. So because you got 440, I think I covered this example in one of the previous lectures, didn't I? Hello?
I don't think so. We have this lecture. We don't have this presentation.
I didn't give you the presentation, but I actually covered this in one of the lectures. I can give you if you want, but this is not in this course. That's why I did not give you. I was teaching another course. I have a lot more lecture notes, so don't ask me if you want. I will be able to give you a lot more and it will overwhelm you. So today you go to the bank and ask 10,440, put this 440 in your pocket, and then, okay, 10,440, the interest rate is 835, and then you total is this at the end of the year, and your revenues is 5,000. So that means you paid off, not revenue, cash flows, right? And you paid off. And you still need to pay that much money, and the interest on that for 1 year is this much, and the end of the year you need to pay that much money. Then next year you got $4,000 profit, you pay it off, and your remaining money that you need to pay, and the interest on that is 222. Add them together, that you get 300. You paid and you paid off. But today you took 10,440, investment was only 10,000, so 440, right? 440 is money in your pocket today. Imagine all of them in thousands. This will be 440,000. Instead of, doing the project yourself, you recruit somebody to do it for you. Okay. So the first year, second year, third year, right? 4 years, like from here to here is 1 year, another year, another year. So 3 years actually you are working on the project. So you're only paying $300,000. You can actually put the money, $140,000 in your pocket. Okay? So you put $300,000 and recruit somebody and pay him salary. And you, because this money, today money, you can even give him an increment of 8% next year. And increment can be compounded again, a little bit more increment. All right. So you can plan another project. Somebody is working on the project. So you can actually, this can be like, starting a petrol bunk or something and operating it. The future is uncertain. So you don't know. IRR is, okay, internal rate of return. So profit, benefit to cost ratio is also called profitability index. So benefit to cost ratio, I told you earlier, that is also called profitability index because the benefit is on the top and the denominator is, so benefit divided by, okay, cost. So profitability index. If it is greater than 1 is good, less than 1 is bad. I think that's it. We'll stop it at this place. So the next class will be covering the depreciation. Okay?
Yes, sir. I have a question.
Go ahead.
Are we going to get the midterm exams to see that, okay, where we
You
made
can you can
mistake?
come to my office. I sent an email. Did you see it?
No?
I sent an email today. Did anyone see it, please?
Yeah, I saw it.
So that means what is it saying?
I think it said to come on Monday. I
Yeah,
have to email you first.
next week, 2 days I will be dedicating for showing you the midterm exam back, Monday and Wednesday. So because we are moving to the online mode of teaching, so Fridays there is no office hour. So office hour is in person during the daytime before 5 for sure, like 4:30 to 5:30. On Monday and Wednesday, you should let me know you're coming. Then I'll wait for you. Because if I go there, and if your office hour, you come by 4:30, okay, I'll be there for sure. And I'll show you your exam. And I'll show you the solution also. All right?
Sorry, sir. So for the midterm, is it possible if we cannot come and see you, is it possible that you just gave us the questions? I mean, not our question. I mean, just the midterm exams questions, so we can use it as a reference for final.
No.
Okay.
I don't give you back because some of the questions can be the same question.
No, I just okay. And do we know when is the final exam scheduled?
I think all of you know, right? No?
We don't. No, we don't. I don't think so.
No, we don't have the time.
Not yet? I think I know. Let us
So
go
only
back.
3 lectures left.
But I should not really tell you because you know what? Tomorrow, if they change it, I'll be responsible, no? Because if they did not tell you, means officially they tell you, not me. If I tell you, then there is a problem. Then tomorrow they change it. So I can certainly tell you, but you have to still look at your back. Not me. Don't count me. Tomorrow they change it. Don't catch my. Don't crucify me, right?
Thursday, December the 4th,
I think so. Yeah, December the 4th.
19 to 22.
Absolutely.
3 to 2.
Absolutely. You
So
are
if we come to the office and just take a look at our paper
sure.
term
I will.
exam,
I will
how
help
long?
you.
Yeah, how long do we have time to check it? Because we want to just see where we made the mistakes, so don't repeat the mistakes in the final exam, right?
These are not very big, so you will only look at what mistakes you made, not really like everything, right? Isn't it? I'll give you, and you check which one is wrong, and then you check that one in detail. I'll give you the computation. It's not big computation. These are very, very tiny computations. I can show you the computation, how to compute it, each number, right? Don't worry, I don't think you will take more than 15 minutes. The exam itself was only 1 hour,
No, it's
right?
not just taking the 15 minutes. The problem is there are so many students, even if you just want to stay in front of your,
No.
you need to
Don't,
wait for an hour that
no. You come on Monday, you will only find maybe 5, 10. Not so many students. We have so many students in the class, but look at how many students are attending today class. Can you see it? Can you see the participants?
80%.
Yeah, 18 people, 20 people, maybe 30 people, maybe 40 people. So attending. These people care. The remaining people don't come. Some people don't come because they already got 25 out of 25, but not 25, but 24. So they won't really come because they know that they made a mistake. And some people are happy they don't come. Some people are, unhappy totally. They already probably are not in the course. They already dropped the course out. You understand me? Don't worry about it. You'll get enough time to see it. Okay? Okay. And your happiness is my happiness. So you should say, okay, then I'm happy.
Okay.
Thank you.
Yeah.
So I'll help you. If you need more, you can still come back, Go ahead, GR. Please ask a question. You have to unmute before speaking. Hand raise, right? Hello?
Thank you. Bye.
Ask me. Okay, thank you. Some question is coming from GR, raising the hand there. I see the GR raise the hand, but is not speaking. Hello? I think that's it. You wrote something in the. Is this recording going to be posted? Yeah, for sure. I'll post it in the model. Your mic doesn't work. Okay, all right. What can I do then? Okay, you can write in the message, chat message. Then I can.
Sir,
Yeah, go ahead.
just to ask, so in case I come on Monday, am I allowed to like take notes of the question I
No,
missed?
no, no. You just look at it and try to understand that. That's it.
All right.
Okay. I will probably let you see it and then try to understand it. I will help you, but not. I won't give you the question back. I won't let you take photos of it. You understand me, right? But I will certainly help you. Read the question along with you and then answer your question and how to solve it. You seem to be a very good student, so you should be fine. All right, I'm closing it now. If you agree,
Yeah, okay. Thank you.
thank
All
you.
right. Thank you, sir.
Goodbye now.
Goodbye.